So hi guys, this is a walkthrough of some basic shellcode that we're providing for contest 1. So this shellcode actually makes it super easy. Um, so this shellcode makes it a bit easier because we're handling most of the data input and output, right? So all you have to do is like focus on making the machine learning model as good as possible. And so, for those who are, this is maybe their first time looking at any sort of machine learning stuff, or even first time looking at any sort of Python stuff, hopefully this walkthrough should explain or at least give a brief overview of how to do like this data IO, and also set you up to make um, the model that you can use for the first competition, right? So if you haven't already watched the Google Colab introduction, then maybe do that first. That's also linked on this. That's also a video that was posted under the same channel. This is a Google Colab notebook, and you will have this link, and you can basically just copy this notebook and make the changes that you need to actually make your model. But I already ran all the cells in this model, so we're going to basically walk through it, explain what each cell does, um, and hopefully set you up to, get a submission up on the first contest, right? So right off the bat, we're importing these two libraries. So Python, um, basically, lots of programming languages have this, but you can import um, libraries that other people have written, if you have them installed on your system. Google Colab, if you're I believe if you're running on the hosted runtime, which is this, then you can all standard machine learning libraries come pre-installed, so you don't have to install anything on Google Colab. Um, so we're importing these two things. Pandas is basically a way to, I mean, there's a lot of functionality that Panda provides. We're basically using it to read in the CSV files and make our lives easier, um, by setting it up to train the machine learning model. It's just basically the data IO portion, and then NumPy is just converting um, the data that we get into NumPy arrays that can be passed on to train a machine learning model. And NumPy arrays are a bit different from Python arrays. Um, they offer some more features, and they're better optimized for like the sort of numerical computations that happen when uh, we're training machine learning models, right? This line is pretty important. So once you go to Kaggle and you download the CSV files that are for this competition, if you're doing this on Google Colab, you have to upload these to Google Drive, right? So going to the Google Drive, this is how I set it up. This is my home like directory on Google Drive, I guess, if that's what you call it. This is the Collab notebook, and I've just put all the files. Submission is actually something that you won't have right off the bat. Like, this is a result of running this notebook, but these two things I put in. These were downloaded from Kaggle, and I just uploaded them to Google Drive, right? And if you click on them, uh, you can see like this, the data, right? And so this is just this raw CSV file that we uploaded. And just to give you a clue into what these files look like, uh, in their raw format, I've just opened these files in uh, and so you should have it in this sort of format, right? Yeah, have the files stored like this, and then when so basically you need to give Google Colab access to these files in your Google Drive, right? It doesn't have those off the bat, so you run this line of code that introduces some functionality to connect with your Google Drive account, and then you say drive.mount, and then what it'll do is it'll establish a connection that Google Colab can use to access all the files on your Google Drive. You'll need to go to this URL, and then it'll give you an authentication code that you put in to a text box that'll appear here. And once you have that, you're good to go, right? And then you can use it just like you would. You can basically have lines like this that normally wouldn't work, on your Google Colab. So this line basically creates something called a data frame. A data frame is the sort of standard way that Pandas organizes data. Um, it's basically an overhauled two-dimensional matrix that has, a bunch of tricks up its sleeves that makes it easier to handle, right? So if you read this CSV file, we provided the exact path from Google Drive, right? So you have to say content drive, my drive, and then this means that you're in your home Google Drive folder, and then we just give it train CSV, which we already put there. And then that creates this, we can basically read the whole CSV in one line, right? It's these libraries make it super easy for us, especially for these kind of like pretty standard things like data IO. So that's pretty cool. And thing with Google Colab is like usually if you just wrote this in Python, nothing would happen. But you have to say like print. But when you have it like this, basically it outputs this in a really nice, easy to view format, and so you can see all of the column headers here. Um, and yeah, this is a data, and it shows you the first couple of elements, the couple of rows of the CSV file, and the last couple of rows. And you can see the dimensions. We have 12 columns, 11 of which are features, and then the last one is what we're trying to predict. And we have 4,000 entities, and this is our training set, right? So in order to train the machine learning model, we want to split this data frame into um, the features and the labels. As I mentioned in the introduction to Kaggle video, the features are what we're going to be giving in to the machine learning model, and then the label is what the machine learning model has to output, right? So X here is going to be basically um, the features, and Y are going to be is going to be the labels, right? So this is just an index, a way to index these data frames that Pandas offers, right? So um, basically, you put in these two square brackets, and you get all of these things. You put in all of the indices that you want in this, and then it'll kind of make a sub data frame of this data frame, right? So we now for the features we only want these. We don't want cardio, so I just put all of that. This is the label, so this is extracts this row, the last row right here. And so if we print both of these, in the same way that we did above, then we have, you know, this is X, which has age, gender, height, weight, and then it stops at active, which is the last feature that we have. And then the Y, which is the labels, just has one column, which is cardio. And so that's what we want, right? Um, this is just some analysis of the data. First, we convert both X and Y to NumPy arrays, and then basically this checks for this is just a way to count the number of zeros and ones in the in the in the y y numpy array or numpy matrix or numpy array. And so basically this counts up the number of people who do not have cardiovascular disease, and this counts the number of people who do have cardiovascular disease by finding all of the um, values in this that are 1, and then this finds all the values that are 0, right? And so by doing that, we can basically count up the number of people who have cardiovascular disease and who do not. And so that's just a way to get a better understanding of our, so here's the cell that you should train your machine learning model. Basically, I'm not gonna show you how to do that here. I think if you go to these links and read through the APIs that this library provides, it should be fairly straightforward to get this working. Now that said, machine learning is not just like using libraries and then like plugging and playing, right? You have to understand what's going on. So this competition basically tests your ability to code up these things by using libraries. Um, and that's just a small part of actually knowing machine learning, right? It's not just using libraries and then um, doing stuff. So we've provided a bunch of learning resources for this, basically past lectures that we've given on actually understanding the theoretical aspects of these models, and we'll probably release videos. We'll definitely be releasing videos throughout the year as the school year begins, but we may also release videos throughout the span of the competition that explain, how these algorithms actually work. We wanted this competition, however, to be as easy as possible. You may not have had previous machine learning experience, and so this is just kind of um, this competition is basically uh, trying to figure out how to use the scikit-learn library to do this as well as possible. And once you create a scikit-learn model, I recommend that you um, mess with the hyperparameters and try to improve the performance to as much as you can, right? And so put your code in that creates the scikit-learn decision tree or random forest model here, and then after that, you should move on, right? So the next step is to actually predict the values in the test, right? In the test.csv file, where we give you all the features, but you need to predict the output. So we're doing a similar thing by creating another pandas data frame, and once you display this, you can see there's this new column that wasn't in the train, called ID, and we keep that there because a Kaggle requires that, at least for the submissions, you have that ID column. But everything else is the same, right? These are the same columns as the previously mentioned 11 features, and the goal is to use your machine learning model to use these features and predict output labels for the last category. And so, after this, we're just converting first we're taking the subset of this data frame that just involves age, gender, just the features. We're kind of ignoring the ID column for now and converting that to a NumPy array. And then you get this. Basically, it's a NumPy matrix where each row is one row in this data frame, right? And so we basically have all of the different entities that we want to predict on. And so previously I had named my classifier that I wrote here CLF. And so scikit-learn provides these methods for both its decision tree and random forest models called predict, right? And you can just pass in a NumPy array of this form, and then on all of these features, it will run your classifier that should be trained by now, and then output the label cardio right here. It should output that. And so now we have this, basically this is also going to be a NumPy array called answers, and basically this line inserts it into our data frame. 12 is the index of the column, and it'll insert answers into here, right? So now you see this is df test. Previously, df test did not have this column, but now it does, right? And so we've inserted this, and to make our submission, pandas also gives this really nice functionality to write a file to a CSV. We just first index, we want to get the ID and the cardio. We only want those two things, right? We don't want to write any of these things to the file. And once we have those, we just write that to CSV, give the proper path to the file name, and you want to say index equals false because we already have, basically if you say index equals true, which is the default option, it'll also create a column that inserts all of this stuff, right, this last column, but we already have this ID column here, so we don't, and since we're writing that to the file already, we do not need to have this index part. And once you have that and you run this block of code, hopefully, if everything went well, you should have a submission.csv file. And if we open this up, you can see the columns are ID and cardio, and you can just take this file and submit to Kaggle. And yeah, hopefully you found this helpful. If you have any questions, just email or comment below. And yeah, good luck.